We're going to keep going with the integral as an accumulator function questions. This is on your worksheet, functions defined by integrals. So the first question here, so we have a graph of g of x or of f of x, and g of x is defined as the integral from 3 to x of f of t dt, and this is the graph of f. And so we're going to use that to find g. So the first one is find g of 10, find g of negative 3. So g of 10 would be the integral from 3 to 10 of f. So you just need to find the area from 3 to 10. Well, we have a half circle here, and this distance is 4, so the radius is 2. If it was a whole circle, the area would be 4 pi. It's a half circle, so that area is 2 pi. And then we have a 3 by 1 triangle, which means that area is 3 halves. So g of 10 is 2 pi plus 3 halves. G of negative 3 would be 3 to negative 3 of f. And so we want to switch the order around. Put a negative out front, and you can switch the order around and then add the area from negative 3 to 3. And so we have to break that into parts and just use a little geometry again. Anything below the x-axis is negative. Anything above the x-axis is positive. So we have a triangle here that is a 1 by 1 triangle, and so that area is a half. It's actually, I think, missing a coordinate. I think you kind of have to estimate on this one. So the area there is negative 1/2, and the area from here to here is a triangle that is, you can't see the 3 up top there, that's the coordinate 1, 3. But this is 5 by 3, which is 15. So it's a triangle, so it's 15 halves. So that's 14 halves, which is 7. So the g of negative 3 would be negative 7. Find g prime of negative 1 and g double prime of negative 1. G prime of negative 1, g prime would be f of x. So g double prime would be f prime of x. So f of x at negative 1 would f of negative 1. We're just going to look at the function value at negative 1. And so at negative 1, the function value is positive 1. And again, it's missing a coordinate. You're estimating because it's a consistent slope. So f of negative 1 is 1. G double prime of f prime of x is f prime of negative 1. So we need to find the slope at negative 1, which is this slope right. I'll use a highlighter. Slope right here, which would be, you can just do slope formula. Y minus y over x minus x. So 3 minus negative 1 over 1 minus negative 3, which is just 1. Whoops. For the second one, or for the part C here, Determine x values where g of x has a relative minimum or maximum. Give a reason for your answer. Mins and maxes occur when the derivative is 0. We said the derivative of g of x is f of x. So where is f of x 0? If you go back up to your graph and we look at the places where f of x is 0, it's here, here, and here. So -2, 3, and 7. And if this is like looking at the graph of the slope, and so where f of x changes from negative to positive is a min, and where x changes from positive to negative is a max. So the only place we have a change where it crosses the axis is at -2. So you would say at x equals -2 there's a min, and your reason is that g prime changes from negative to positive. That's always your reasoning, whether you're looking at the graph of the slope or a graph which represents the slope. The last part here is from -3 to 10, find all values where the graph of g of x has a point of inflection. Point of inflection means g double prime equals 0 and the sign changes have to be both. Can't just be where g double prime is 0. So g prime was f of x. G double prime is f prime of x. Sorry, I forgot to include the 0 or undefined. So those were possible inflections happen. So in this case, the slope is undefined at 1, 3, and 7. So now we need to test and say, okay, at x equals 1, 3, and 7 are possible. Does the slope change signs? So the slope of our graph, does it change signs? Well, at 1, the slope is positive, then undefined, then negative, so that's an inflection point. Negative, then undefined, then positive, that's an inflection point. And negative, then undefined, then positive, that's also an inflection point. So all three of these are inflection points, and your reasoning is that f prime of x, which is g double prime, changes signs. And that's how you use the graph in a little geometry to answer the questions about integrals of another function.